Hi everyone, my name is Steven and thank you for watching my Kickstarter video about fRISCy. Let's get right into it. What is fRISCy? fRISCy is a PCB designed for any digital processing application, but its main target is either system development or industrial uses. The primary features include a SiFive Freedom E310 Microcontroller and a Xilinx Artix-7 FPGA. I've also added the new SYZYGY Standard carrier side connector for peripherals. fRISCy is built in the same form factor as a Raspberry Pi, including the mounting holes and placement of the USB connector, RJ45 jack, and 40-pin GPIO header. Some of the other major components include an FTDI device to translate USB to JTAG for the FE310, a 10100 Ethernet PHY connected to the FPGA, and a 4 megabit SRAM device also connected to the FPGA. The FE310 is intended to be a system controller and is connected to the FPGA through a SPI interface and a few GPIOs. Next, let's jump right into the system architecture and explore the block diagram. So, here's the block diagram for the fRISCy board. First, let's look at the primary processing devices. We have the SiFive Freedom E310 RISC-V Microcontroller, as well as the Artix-7 FPGA. Also shown here is the SPI interface, an I2C interface between them, and 3 GPIOs. Additionally, the wake and reset switches are shared between both the Freedom E310 and the Artix-7 FPGA. The E310 also has a 128 megabit QSPI Flash for program memory. We also have an FTDI USB to JTAG device for programming the E310. Next, we'll look at the connectors. Primary power is provided by a USB micro B connector, which also provides the USB 2.0 interface between a host device and the FTDI device. The 40-pin GPIO header conforms very similarly to the Raspberry Pi header. There's a Xilinx JTAG connector for programming the FPGA and its flash memory, which matches the standard Xilinx JTAG connector pinout. We also have a SYZYGY carrier side connector, which has 8 differential pairs and 12 single-ended signals, as well as 2 differential clocks. SYZYGY is a peripheral connector standard just released by Opal Kelly, which fits nicely between PMOD and FMC. Lastly, there's an RJ45 connector connected to the 10100 Ethernet PHY. Next, we'll look at the clocking system. The FPGA has a 100 MHz system clock provided by a CMOS oscillator. The Freedom E310 uses a 16 MHz crystal for its main clock and a 32 kHz oscillator for its RTC clock. Finally, let's look at the different memory devices on board. There's a 4 megabit SRAM device with an 8-bit wide data bus connected to the FPGA. There's also QSPI Flash for configuration of the FPGA. There's QSPI Flash for the E310's program memory, and there's an EEPROM for the FTDI device. Lastly, there's a silicon serial number with built-in MAC address and 256K EEPROM space made by Microchip. Power can be provided over the USB connector or an auxiliary connector, and the main power regulators on the board are one triple output buck converter for the 1 volt, 1.8 volt, and 3.3 volt rails, as well as a 2 amp capable buck converter for the SYZYGY variable VIO voltage. Lastly, there's one RGB LED connected to the E310, and there's one RGB LED connected to the FPGA. For more information on this board or any of its components, please feel free to visit my website, shielddigitaldesign.com.